Imagine going to a car dealership, finding the perfect vehicle, and the dealer just casually mentions that there is a hidden, like, $6,000 anxiety tax permanently added to the sticker price.
Right, which sounds completely ridiculous.
Yeah. I mean, you can't physically see it on the invoice, but you are absolutely going to pay it in pure stress every single time you leave your zip code. If that sounds insane, well, welcome to the hidden reality of the electric vehicle market right now.
It really does sound like an exaggeration, I know.
Yeah.
But that invisible penalty is a mathematically proven factor that's stopping millions of people from making the switch. And it all traces back to one single, incredibly infuriating experience.
Which is, of course, pulling up to a public EV charger with like 5% battery left, plugging it in, and just staring at a completely dead screen.
The worst feeling.
Truly.
Yeah.
So today we are doing a deep dive into the August 2024 National Renewable Energy Laboratory Report, or NREL. Our mission here is to figure out exactly why these public chargers are so wildly unreliable right now.
And how the industry is trying to fix them.
Exactly. And ultimately, why the mere presence of a working charger in your neighborhood is the ultimate key to mass EV option. Okay, let's unpack this immediately.
Well, to set the baseline here, we really have to look at the massive federal push happening in the background. I mean, the bipartisan infrastructure law is investing $7.5 billion into public charging corridors across the country.
That is a staggering amount of money.
It is, but here is the thing. When you look at the data, about 90% of current EV owners just charge at home.
Right.
They plug in at night, they wake up with a full battery, and they rarely even think about public chargers.
Wait, so if 90% of charging happens in private garages, why on earth are we pouring $7.5 billion into public networks?
Because that home charging statistic really only represents the early adopters.
Oh, I see.
Yeah, those are the people with, dedicated driveways and attached garages.
Yeah.
For everyone else, like the driver who lives in a third-floor apartment or the family trying to take a road trip across 3 states public charging is the absolute linchpin.
That makes sense.
Right. If the public network is broken, the entire transition to electric vehicles basically hits a brick wall.
Which means we really need to look at how we measure if that network is actually working. Because I know there are official standards tied to all that federal money, but what I read in the NREL report, I mean, it feels completely disconnected from the horror stories I hear from actual drivers.
Yeah, the official metric is where things get really fascinating. Under the federal mandate, any charger funded by the government has to maintain a 97% uptime.
Okay, I mean, 97% sounds incredible. If my home Wi-Fi worked 97% of the time, I'd be thrilled.
You would think so, right? And the math behind it is pretty rigid, too. There are 525,600 minutes in a year.
I knew you were going to bring out the calculator for this.
I mean, I can't help it. The federal formula literally uses that exact number.
That's amazing.
So to hit that 97% score, a charger can only be quote-unquote down for about 15,000 minutes a year. But the catch, and it is a massive loophole, is what the government officially considers downtime.
Okay, what do you mean?
Well, the formula excludes a shockingly long list of real-world problems.
Wait, exclusion. So if a charger is physically broken, you're telling me it might not actually count as broken?
Exactly. So if a charger goes offline due to like a local grid outage, those minutes are entirely excluded from the penalty.
Oh, wow.
Yeah, and if it's damaged by vandalism or taken offline for scheduled maintenance or hit by a natural disaster, none of that counts against the 97% score.
That is wild.
And it gets worse. Furthermore, the technical definition of uptime basically just checks if the internal hardware is online and if power is technically capable of flowing.
So, let me make sure I'm really grasping this. The network basically just pings the charger. The charger says, yep, I have electricity, and it gets an A+ for the day.
Pretty much, yeah.
But what if, like, the credit card reader is smashed with a hammer?
In many of these reporting systems, a broken payment screen or a jammed card reader just isn't categorized as hardware downtime. Because, again, the power is technically there.
That's like, I don't know, it's like a restaurant putting up a massive neon open sign, right?
Yeah.
But the front door is dead-bolted and the cash register is on fire.
Yes.
Sure, the chef is in the kitchen with food, but it is completely useless to a hungry customer out on the sidewalk.
That restaurant analogy perfectly captures the frustration, honestly. The metrics are measuring the electricity, not the driver's actual experience.
Hmm.
And that loophole completely explains the jarring discrepancy between the official government reports and independent surveys.
Right, because the surveys tell a totally different story.
Yeah, exactly. J.D. Power surveyed, I think, 15,000 EV drivers and found that 14% of visits to public chargers end without a charge simply due to malfunction.
14%. So that is roughly 1 in 7 attempts failing completely.
Yep.
I mean, I wouldn't go to a gas station if I had a 1 in 7 chance of the pump just refusing to give me fuel.
Nobody would.
Yeah.
And depending on where you live, it's actually far worse. Like in the Denver Aurora area, that failure rate spiked to 29%.
Almost a third of the time.
Yeah. And another study by UC Berkeley and Cool the Earth looked at the California Bay Area. They found that only 72.5% of the standard CCS fast charging connectors were actually functional.
Wait, CCS, for the uninitiated, that's the bulky plug that most non-Teslas have been using for the last few years, right?
Yes, exactly. The combined charging system.
Yeah.
It's been the industry standard for a long time now.
Okay, got it.
So nearly 30% of those specific chargers in one of the biggest EV markets in the entire world were just straight up dead or malfunctioning.
Okay, so if the problem isn't the electricity itself, since we established the chargers often have power humming inside them, what is actually breaking when I plug this thing in? Are the cables physically snapping?
Well, to figure that out, the government and the industry actually formed the National Charging Experience Consortium, or ChargeX.
Right.
They gathered over 50 organizations to really diagnose the network. And they identified more than 50 specific pain points.
50. That's a lot of ways for a machine to break.
It is, but the vast majority of failures, 18 of them, in fact, fall under a single complex category, which they call starting a charge.
So just the initial handshake, like literally just getting the machine to wake up.
Yes, and we really need to understand what that handshake actually entails, because when you plug in a toaster, electricity just flows, right?
Sure.
But an EV charger is essentially a highly advanced networked computer. When you plug the heavy cable into your car, the car has to securely tell the charger its make, its model, and its exact battery state of health.
Oh, wow. I didn't realize it sent all that data.
Oh, yeah. And then the charger has to verify safety protocols, check the physical temperature of the liquid-cooled cable, and then ping a cellular tower to authorize like a $5 hold on your credit card. All of this data has to bounce back and forth to the cloud in absolute milliseconds.
Okay, so it's really not a plumbing issue at all. It's an IT issue.
Heavily. EV Connect, which runs a very large network, looked at their data and found that 55% of charging failures are simply station connectivity problems.
Just the Wi-Fi drop-in?
Basically, yeah. The charger drops its cellular connection to the internet. And if it can't reach the network, it can't authorize your payment, so it just flat out refuses to dispense power.
That is incredibly frustrating. Like, you have a 1,000-pound battery in your car, you are standing directly on top of a massive underground power line, but you can't connect the two because the charging station has a worse cell signal than my basement.
Exactly. What's fascinating here is when you compare it to the alternative.
Right, wait, because gas pumps are outside too. They deal with rain and snow, and they use cellular data for credit cards. Why is a screen on an EV charger so much more fragile than the one at my local Shell station?
Well, it really comes down to market maturity and regulation. Gas stations are a highly regulated, century-old industry. A typical gas station pump is built with around 60 UL-listed components.
UL listed meaning what, exactly, in this context?
Underwriters Laboratories. It basically means the specific internal parts have gone through rigorous, standardized safety and durability testing over decades to prevent things like fires, shocks, and everyday wear and tear.
Oh, okay.
Gas stations also face extreme EPA regulations, which forces really strict oversight on the equipment. But crucially, there is almost always an on-site attendant.
Ah, of course. Right, if pump number 4 is frozen, you just walk inside, buy a pack of gum, hand the attendant $20, and they manually override the pump for you.
Exactly. Plus, just the mere presence of that attendant deters vandalism. EV stations, by contrast, are essentially unattended smart devices just sitting alone in dark parking lots.
That's a really good point.
They take a massive beating from extreme heat, dust, rain, and a lot of the durability standards they do face are focused entirely on electrical safety. Making sure they don't electrocute someone, rather than whether the internal modem can survive a software crash or if the LCD screen can survive someone dropping a heavy charging handle directly against it.
It sounds like we are essentially treating EV chargers like rugged metal vending machines, when in reality, they need the active, continuous IT support of a complex data center.
That is exactly what's happening.
Which naturally makes me wonder, whose job is it to play IT support? If the screen goes black at a charger in the back of a grocery store parking lot, who pays to fix it?
Historically, nobody wanted to pay for it.
Really?
Yeah, the legacy business model in the EV charging space was fundamentally flawed. Hardware companies made their money by selling the massive, expensive physical charging cabinet up front to a site host.
And by site host, you mean like the mom and pop grocery store or the local pharmacy?
Exactly. The hardware company would sell the unit, maybe collect a tiny recurring network software fee, and then just walk away. There was very little financial incentive for the manufacturer to maintain the equipment long term.
So they just wash their hands of it.
Pretty much. Once it was installed, maintenance became the site host's problem entirely.
But is it realistic to expect a local pharmacy manager to troubleshoot a high voltage direct current machine?
Mm.
I mean, they sell aspirin and greeting cards. Plus, maintenance on these things cannot be cheap.
It definitely isn't. The NRAO report points out that basic maintenance averages about $400 a year per standard charger.
Wow.
But if you have a DC fast charger, the massive units that can charge a car in 20 minutes, extended warranties and maintenance plans can easily exceed $800 per year per charger.
I just can't imagine a grocery store owner happily paying $800 a year to maintain a machine that barely makes them any profit on the electricity sold. It feels like the incentive structure was just doomed from the start.
The industry has finally realized this, actually, which is why we are currently seeing a massive shift toward new financial models, primarily things like reliability as a service or rated tech as alongside charging as a service.
Okay, so how does reliability as a service change the math for that grocery store owner?
Well, instead of forcing the site host to play electrician and IT guy, companies are stepping in to take ownership of the continuous operation. Take a startup like Charger Help, for example.
Okay.
They offer a subscription model. For roughly $100 a month per station, they take on the risk. They literally guarantee that 97% uptime. If the machine goes down, their remote sensors detect it, and they automatically dispatch a technician.
That seems like a massive step forward, especially since, you can't just send a residential plumber or a standard home electrician out to fix a proprietary software glitch on a machine pumping out 150 kilowatts.
You absolutely cannot, which is exactly why Charger Help and similar companies are partnering with organizations to build specific EV charger technician certifications completely from the ground up.
Oh, that's smart.
Yeah, they are creating a brand new, highly trained workforce. And thankfully, the hardware itself is finally evolving to make their jobs a lot easier, primarily through modularity.
Meaning the machines are built more like Lego bricks.
Precisely. In the past, if a specific power inverter inside a DC fast charger failed, the site host might have to wait 1 to 3 months for the manufacturer to build and ship a custom replacement part.
3 months. With a black garbage bag taped over the screen in the parking lot. I mean, we've all seen them.
Right. It was a terrible look for the industry.
Yeah.
But with modularity, the internals are built as hot swappable blocks.
Okay, so how does that work?
If a power module fails, a technician can just unlock the cabinet, pull out the broken module like a heavy server blade, slide a brand new one in, and the station is literally back online in 10 minutes.
Wow, that's a game changer.
It is. The broken part just goes back to a lab for repairs, rather than holding up the driver on the street.
So what does this all mean? This all circles back to you, the listener. We've talked about IT failures, cellular modems, and modular hardware. But the ultimate question is, does any of this actually dictate what kind of car you buy? Does a broken screen at a strip mall stop someone from taking the plunge into the EV world?
The data on consumer psychology is overwhelming on this. The Associated Press and the NRRC Center for Public Affairs Research conducted a massive survey, and 80% of people cited a lack of charging infrastructure as the primary reason for not buying an EV.
80%? I mean, that is an absolute wall.
And Consumer Reports looked at the inverse, too. What is the strongest incentive to get someone to buy? Free public charging was the #1 answer.
Really?
Yeah, it beat out workplace charging, and it even beat out home charging availability.
Which brings us to a major contradiction, I think. Because we established at the very beginning of this deep dive that 90% of early adopters charge at home. If the ultimate goal is for everyone to just charge in their garage overnight, why is public charging the #1 barrier to entry?
Because humans don't buy cars based solely on daily utility. We buy them based on edge case anxieties.
Oh, that's incredibly true.
Right. NREL uses a fascinating consumer choice model called ADOC-ET, the Automotive Deployment Options Projection Tool. To accurately predict EV sales, researchers can't just look at battery range and sticker price. They actually have to mathematically calculate human fear.
This goes back to that $6,000 anxiety tax we talked about at the very beginning. How does a computer model even begin to quantify fear?
The ADOC-ET model applies an inconvenience factor. It calculates the anxiety of long-distance travel, the fear of pulling up to a broken charger, the frustration of juggling multiple proprietary smartphone apps.
Ugh, the apps are the worst.
They are, and it also factors in the slower refueling times compared to a regular gas pump. It aggregates all of that friction and translates it into a literal financial penalty in the consumer's mind.
And what does that number come out to?
That penalty can equate to up to a $6,000 hurdle on the equivalent purchase price of the car.
That is profound. So I might look at a $40,000 electric car, but my subconscious is treating it like a $46,000 car because I am terrified I'll get stranded in the rain with a dead cell connection.
Yes, exactly. And when NREL ran various future scenarios through this model, they discovered something really crucial for policymakers.
Which is?
A high infrastructure scenario, meaning we aggressively build out reliable, dense public charging networks, is actually a significantly more cost-effective way to boost nationwide EV sales than simply throwing huge financial subsidies directly at the vehicles themselves.
So even if 90% of EV charging happens at home, a working public charger isn't just a utility, it's basically a giant psychological billboard for EV adoption.
Precisely.
Just seeing a bank of chargers at your local grocery store and seeing that the screens are actually turned on makes you feel safe enough to buy the car, even if you only end up using those chargers twice a year for a road trip.
It acts as a safety net. And if you zoom out to the global context, you can see how thin the American safety net really is right now. Yeah, right now, the United States has roughly 40 battery electric vehicles for every one public charging port.
40 cars fighting over one plug. I mean, that sounds like a recipe for absolute line rage during Thanksgiving travel.
It certainly can be. By comparison, in Europe, that ratio is much denser. It's about 15 electric vehicles to every one public port.
Okay, that's much better.
And industry analysts suggest the ultimate sweet spot for a mature market where range anxiety essentially disappears entirely is somewhere between 8 to 12 EVs per port.
So we have a massive gap to close. And as we've learned today, closing that gap doesn't just mean pouring concrete and dropping metal boxes with dead screens into parking lots. They actually have to communicate with the network.
We absolutely have to move past the uptime loophole.
Yeah, we started today by dissecting that 97% uptime metric, realizing that a charger can be perfectly compliant on paper, but completely useless to a driver if the card reader is jammed or the cellular modem drops out. We explored the messy reality of the handshake, the fact that these are fragile computers requiring actual data center support, not just rugged gas pumps.
Yep.
And we looked at how the legacy business models left site hosts completely abandoned with $800 maintenance bills, and how new reliability as a service subscriptions are bringing trained technicians and hot swappable modular parts to finally clean up the network.
And ultimately, we proved that infrastructure is a psychological product.
Exactly. So to you listening, if you are sitting on the fence trying to decide if your next vehicle will be electric, you aren't just waiting for battery chemistry to improve. You are waiting for these new maintenance business models to clean up the streets in your specific neighborhood.
You really are.
You are waiting for those psychological billboards to light up and stay lit, erasing that invisible anxiety tax once and for all.
And that leads to one final, deeply consequential thought, building off the hardware standards mentioned in the NREL report.
Oh, what's that?
Well, we talked earlier about the bulky CCS plug and its high failure rates. The report notes that NACS, the North American Charging Standard, which is essentially Tesla's proprietary vertically integrated plug, is rapidly becoming the universal standard.
Right.
It currently holds about 2/3 of the market. And Tesla achieved that high reliability by controlling both the software handshake and the hardware design from day one.
Okay.
So we just discussed how reliable infrastructure drives consumer adoption far better than vehicle subsidies, right?
Yes, absolutely.
This raises a fascinating question to leave you with. If public infrastructure dictates the speed of mass adoption, does that mean one single private company's historic investment in a reliable network has essentially become the most powerful driver of national public transportation policy?
Wow, that is a brilliant, heavy thought to leave on. Whoever controls the plug and actually keeps the screen turned on basically controls the future of the roads. Thank you so much for joining us on this deep dive into the charging network. Hopefully, the next time you pull up with that 5% battery warning flashing on your dashboard, the screen is bright, the handshake is instantaneous, and the power flows perfectly. Until next time, keep exploring.